All right. So I want to get into explanations again, and especially human-centered explanations today. So last time we focused mostly on the mechanisms of how to explain things, what are the techniques. Today I want to talk much more about applications of how do you design explanations for a specific purpose, like thinking about what do we want to achieve and do we build the right explanation for this. This is where you're going to do this on your own in the homework assignment starting next week. It's a screening tool for diabetic retinopathy, which is an eye disease that affects diabetic people. So if you're diabetic, if Claire was here, she could tell you much more about this. They get screenings at least once a year. It's a very treatable disease if it is detected early. But it's still the leading cause of blindness in the US, and it's much more severe in many other countries where screenings and diabetes treatment are less common or less pervasive. So the scenario here is that, so there are several of these devices on the market. This is actually, not this specific one, but diabetic retinopathy screening was the first FDA-cleared medical device with machine learning in it. It's something where we have a lot of training data. We got really good on benchmarks, and now there are actually many different competitors on the market. And there are actually several startups that also build this for worldwide markets there. What we're thinking about here is a scenario where let's see whether we can find a low-cost solution. Again, there are startups that work on this that we can deploy into under-resourced areas in the world, like high poverty rates, where volunteers of non-profit organizations could go in, perform these screenings, rather than have patients travel a long distance to a hospital to get these screenings. So maybe run this on a smartphone design, with a lens attached, have an AI device. And the question here is, if we're building something like this, and we're giving you a model, you don't need to train your own model, but you could. There's a Kaggle data set and competition. So the model is not necessarily the important part, but how do you explain what's going on to the patient, to the nurse, to somebody who buys the system, right? What kind of explanations do they want? What kind of explanations can you provide and should you provide? And that's a kind of open question where you need to understand what information do they actually need. And we're going to go today through some of those things. So I don't want to talk about diabetic retinopathy to give it all away in this lecture. We're going to talk about radiology a little bit later, which was your reading. But my main example of this lecture is precision agriculture. Does anybody have farmers in their family? Good, because I wanted an example that you probably can't directly relate to, so that we can later talk about how would we even figure out what farmers want to know from this. Right, so the idea of, has somebody heard of precision agriculture? So the idea here is to use machine learning to be much more deliberate and precise about where to put fertilizer on a field, essentially. So the idea is to use less fertilizer, use it in a much more targeted way, and use the right fertilizer, and also water in the right place. So typically you have aerial imaging, like satellite photos or a plane flying over the field, to detect from above how the soil looks or how the crops look. And they try to give you very precise information in this part of the field. We should apply a little bit more fertilizer, or we should water the field a little bit more. So you have these kind of predictions that a model makes based out of satellite images, for example, vegetation density, water deficiency, crop stress, things like this. This is partially done with vision models. You can also think of having additional soil samples. So the model might tell you, in this area I'm less certain, just from aerial images, so maybe go get a soil sample. And the idea is that you can really, day to day, on a very precise fashion, on a small area of a field, identify where to apply irrigation or like water or fertilizer and so on. Does this make sense? This is actually a big market, both for environmental reasons, it cuts cost. There's lots of companies working on this kind of stuff and trying to sell this to farmers, usually farmers who have larger plots and larger farms, right? So larger businesses. So we're going to come back to this a couple of times today. And the first thing is something I didn't talk about at all really last time. We talked about all these explanation techniques, but we really didn't talk about why would you actually want to explain how the model works in general or a specific prediction. So let's maybe think about this from the farmer's perspective or from the manufacturer of these tools. What could be a reason why you would want to create explanations when you create a system that predicts where to apply fertilizer?
There'll be a lot of friction, like people have done it for however many years successfully, like why do we even need to buy your thing if you're trying to sell us on?
So, sorry, what's the purpose behind this? Is to convince them that it works or that it provides value?
Because if you're like approaching like, say a farmer with a large plot and saying, well, why would we even need this? Like, I've been successful over so like...
Cost cutting, typically. Do you need to know how the model works for that? Do you convince a farmer by telling them how the model works? Like showing them a Shep plot?
It could be to be able to detect things like, let's say, label leakage. Like I'm not an expert on the data and how it works, but if I rely on a piece of information that the farmer would say, actually, this is like we don't have that piece of information you're relying on. We only have it after.
Okay, so you think the farmer would push back against some of the results. So I'm thinking of this as some form of human oversight, maybe, right? Last time we talked about recidivism prediction. Is also, can you understand? Can you, like, let me collect some things. Human oversight. Controlling. You also implied kind of a debugging story, right? Something seems to be wrong here. There's label leakage. I suspect the farmer wouldn't know about the concept of label leakage or would point that out. Maybe I'm unfair to farmers, I don't know. But that's not great. The idea here would be that at least the developers have a chance of seeing, does a model make plausible recommendations, right? Is the, I overlaid it, but is the detection of stressed crops realistic? Like, does it pick up on the wrong things, right? So debugging is a very common thing. So it's used by data scientists to understand the data, and that's, you can look at a photo, you can highlight the pixels, what the model used, right? See whether that's plausible, is this what you're expecting? Are there any other reasons that you could expect why you would want explanation? Why might a farmer want explanations? What do you think they want any?
Maybe to trust the process or whatever change AI is making. Or if it becomes put more fertilizer,
Right.
trade that.
Yeah. So you want the farmer to follow your recommendations, right? You're essentially saying, here, go out there and fertilize in this area. And this goes back to your point, right? How much is the farmer really thinking this is providing any value? So there's a notion of trust. Can I trust this, right? Buy-in. Any other things that you can think of? Let's take the recidivism example from last time. So a model says you should go straight back to jail. Why would you care about an explanation? Or maybe you don't.
Detect biases.
To detect biases, yeah. The word that I'm using for that is auditing. So somebody, maybe not the person who's judged here, but somebody external wants to know, is the model biased, right? So having some explanation, does it use race as a feature, for example, could be useful. Why would the defendant want to know what the model does, or how the model works, or why it predicted that they will reoffend? Is there any reason why you think we should give the defendant maybe an explanation? Or it doesn't matter? You're just going back straight to jail because AI says so.
So there's a case where you could try to, exploit the model by saying, oh, I just skirted that part of the law. But here, maybe you could say, well, instead of reaching a point at which I needed this measure, I could have preemptively done other things.
So if you understand how a system works, you might change your behavior in a positive way or to exploit the system, right? So influencing behavior is one thing. In the criminal justice system, this might be useful. Any other things you were thinking about?
In the context of farmers, I was thinking if they know how the thing is working, they can allocate the resources correctly. For example, if the model predicts that water should go more in this direction, then they can check, because water itself is a resource, so
yeah.
You're paying for it, so all the action directly related.
I'm thinking of this again as trust, kind of, right, or human AI collaboration. Do the people actually follow what the model says? Is this what you're trying to say?
No, they can take actions. It goes to the previous point, but then it directly affects them in terms of money, in terms of time, and they can decide whether they follow this or not.
But doesn't the model already tells you you should fertilize here, yes. Right? Why would you want an explanation on top of that?
Because the farmer probably has a domain expertise, so they know.
Okay. So again, I'm thinking of this as human AI collaboration or human oversight, right? So if you have additional domain expertise, like, can we make use of that, right? That kind of, it's not just a black box. You can actually see when is it right, when is it not right, right? Or is this convincing to me? Should I take an action?
If the model makes some error and the human acts on it,
yeah.
and let's say there are some damages to the crop, the farmer can explain to the insurance company why the model was wrong and then claim an insurance for it.
Yeah. Or the insurance company might just say, well, you followed the model, it's your fault, right? So it's kind of this accountability laundering. We do this with self-driving cars all the time, right? That we blame the human in the car, even though we create all incentives that they're not paying attention, right?
Mostly modeling pattern matching, so out of distribution settings, there's like low frequency cases. The farmer might want to know what decision might be taken. Like, it might happen once in a while, but at least in some sort of understanding.
Yeah, it's again some sort of human oversight. The farmer might have, again, domain knowledge to recognize this is completely off, right? Or we're in a out of distribution thing here where the model makes really wrong claims. I wanted to get to one more point about. Let's actually just go through them. So I have a whole list of reasons here why you might want to explain things, and explanations might look quite different. So debugging is the most common the reason how explanation techniques are used. It's by developers to understand their models. It's usually not end-user focused debugging, right? It's not clear that the farmer or the defendant would have any chance to debug the model or any incentive. This is how we mostly use SHAP values, not for end users, but for debugging. Auditing we talked about, right? Somebody wants to understand, is the model fair? Is the model taking shortcuts? This could be a third party, not just the developers. In the recidivism case, these were journalists trying to figure out how the models work, critiquing it. Human AI collaboration, you mentioned repeatedly, some form of trust. Will the human follow the model's recommendation? Do they buy into this relationship? Human oversight and appeals, we talked about, contestation broadly, right? This is also actually not just human oversight of the judge understanding how the model makes a decision. Have I mentioned this last time? So judges are supposed to, so the model doesn't take the severity of a crime into account, and judges are supposed to judge this separately. But if you're just seeing a number, you have no idea. I mean, it's written somewhere that it doesn't use severity, but it's not that obvious. Whereas if you see all the inputs, you can easily check severity was not used, right? You have more understanding to provide more realistic oversight. And appeals or contestation would be on the defendant's side. So something, for example, if in the US, if you apply for credit and it gets denied, the bank needs to explain to you why it was denied. It's completely ineffective because they essentially get away with something meaningless, but they need to tell you what information was used, or they usually share with you what information is used. So if some of that was wrong, right, so they are basing this on wrong information, you can appeal. Similarly, if the defendant knows the system says recidivism because it had the wrong age, the defendant can appeal, right? So being able to check this in some way can be useful. This, I think, nobody brought up, but I think this is quite useful to think about. Maybe it's a little bit too social sciencey for me, but humans like to be in control and understand what happens to them. If you ever try to read like a Kafka novel, like The Process or something like this, things are just happening and you don't understand why. Like in The Process, somebody gets arrested and nobody tells them why and what's going on, and that's super disorienting and really frustrating to humans. Right? So if you get thrown into jail because an AI says so, and you have no way of understanding this is really undermining human dignity, right? We have no agency, we have no understanding even. So even if it doesn't change anything, just explaining people why something happens. Same, you might think about this with a diabetic retinopathy screening, right? So you get a diagnosis here and you have no idea what's happening. This can be dehumanizing. I actually like this framing from Cory Doctorow about reverse centaurs. In automation theory, centaurs are humans who are assisted by an automation, by an AI. And what we're increasingly seeing is that AI is in charge and humans do the stupid tasks like solving a CAPTCHA or picking something up and putting something into a box. And this is undermining human agencies because you're just doing the menial task that the AI tells you, right? Algorithmic management is a term for this too. Like you're just following tiny steps. You don't know why. You're not buying in. You're just a tiny cog into the machine, and that is usually very unsatisfying. And this is speculation here. Why so many people hate AI, right? When it gets introduced, because it takes away their agency, their dignity. This is a funny, I don't know, funny, but you can deflect blame if somebody gets told they need to go to jail, right? You can diffuse the situation by providing an explanation. Doesn't even have to be the correct one. It's often called a justification of how the decision aligns with some law. And it can reduce the negative experience from bad outcomes. If the bank explains to you why your loan was rejected, you might feel slightly better. You can use it as an excuse and as a justification. We had no choice, no alternative. We are not responsible is one way of explaining things, right? So this is the decision. We followed the process. There was nothing we can do. Sorry, don't blame us. Or as a justification, it was the right thing to do. We were supposed to throw you in jail or decline your loan because you're like all these other people, right? Let me skip this. You talked about this as actionable insights. If you provide an explanation, somebody can change their behavior if they understand how the system works. And then there's also plain, just legal requirements. There's not many of those at this point. In the US, credit decisions have to be explained, and that has happened since the 60s. Like for many, many years, it was the Fair Credit Act in the Civil Rights Package, I think. It's not very effective, but people point to this as a way of trying to fight against biased, intransparent decision-making in finance. In the European Union, GDPR, there was a sentence attached to this somewhere that says that people have the right to an explanation. That doesn't, lawyers disagree on this, but mostly I think the consensus is it's not actually a right that you have. But people talked about this for a lot, and there has been a lot of discussion of whether we should have regulation like this in the US. Right now, it doesn't seem like any laws about AI regulation will be passed, right? The regulatory environment is very different right now. Let it rip and invest in this rather than constrain it. In the European Union and several other countries, there are efforts of demanding explanations for some of this. There's a lot of questions about how effective that's going to be, and you're seeing in your homework assignment next week also that we're giving you a policy, a requirement essentially that you're expected to follow. And the last thing is we can use explanations also for science and curiosity. We use linear models, for example, all the time in science, long before the current machine learning craze, right, where you have a lot of data, you model something, you can predict it, but you also want to know what are the trends in the data. And the story that I like is this one here. It's a few years old now, but there's a lot of people who are interested in figuring out how smell works. We have no good understanding to this day, science-wise, how smell works. We know it's particles, which you don't really want to think about if you smell something in the bathroom, that it's actually particles. You're welcome. But we don't really know how it works, what particles they are, how smell works. However, we have been able to build a machine learning classifier, a robot nose that works reasonably well. It works, but we don't know why. So the step then was, this is about 4 years ago, can we use some explainability techniques to reverse engineer what this deep neural network has actually learned? And I've been looking into this in the last 2 or 3 years. There has been some progress of saying this one theory is probably more plausible than this other theory. So there's actually, not sure that you would show this to an end user necessarily, right? I smell cancer because, but we can build theories, we can build science of this, even if we initially don't even know how this works, right? Just in discovering trends in big data. I find that pretty fascinating, not the main reason for what we're talking about today. But the point that I wanted to make here is that there are many different reasons why we might provide explanations, right? Debugging is the one that everybody first thinks of because that's what the tools are easily for. But pretty much all the other ones focus toward an end user. What do you want to do with this? How do you want to do that? All right. Explanations can be very dangerous in that you can very effectively manipulate people with explanations. There's been lots of studies on this. I'm going to show you a couple of examples. Whenever you provide an explanation, people are more likely to trust you. So let's say you do a medical diagnosis and you tell why the model thinks this is the right diagnosis. A doctor who's going to oversee this is going to believe the model more. It's going to be less critical. It's going to fix fewer mistakes that the model makes. Right? So there's supposed to be oversight there, that somebody independently checks the prediction of the model, somebody with lots of medical training. But if you provide explanations, it doesn't even matter whether they're correct. If you provide explanations, the human tends to trust the model much more. Right? So if you want somebody to follow what you're recommending with your system, whatever you're designing, right? If you want them to watch your movies more, try to provide them explanations. And again, it doesn't really matter whether they're correct. They should be plausible, right? We talked about the Rashomon effect last time. There are many different explanations, so you can kind of pick and choose. This, to me, is very scary, right? Because it's really straightforward manipulation. And I think you need to be careful about not doing this accidentally. If you're doing this intentionally, I don't want to hear about it. You probably shouldn't, right? Humans will make up their own explanations if none are provided. It's another really simple old experiment where people were given a sentence, and then there was early sentiment analysis technique essentially telling you how positive that sentence is or something like this. And they played with this, making this a random predictor. And people would come up with explanations. Oh, the model probably thinks this one word is very negative, or this thing here is very positive. Right? So if you don't provide an explanation, people will make up their own, and they are often incorrect. And if you have an incorrect mental model of how a system works, you can't correct it, and you're often misusing it in the long run. Another study that I really like is a really stupid experiment in a way. It's like a Frogger-like game that they showed to people, and they tried to give people 3 explanations. This one here is so this one is just a baseline saying what the robot has decided to do. It's just stating what the prediction is, right? The next action. Any idea what this might be? These are Q values in some internal, what's this reinforcement, internal planning thing? I don't know that anybody knows what they mean in a meaningful way, right? But they're internal values. And this, I think, was an attempt at trying to explain kind of the context and where we are. And they tried this both with experts and with non-experts. And people often preferred this explanation. Non-experts said, oh, there's something going on here, and the model makes some reasoning here. I don't understand it, but it looks like the model is thinking. Experts were realizing, oh, it's Q values, so the model probably does something here, even though they couldn't understand it. They really over-trusted numerical explanations, even though were inscrutable to them. They also liked this one, even though there wasn't any useful explanation. This one too. There wasn't a huge difference, I think, between the conditions. But it's again another sign of these things. You can provide almost any explanation out there, and people will initially believe you or think that they don't understand this. We got this a lot with some explanation designs where if you try to ask people, what do you want to know about a model, it's usually, I don't know, I wouldn't understand it anyway. But you can show them meaningful things if you figure out, they won't tell you, but you can often figure this out. We're coming back to this in a second. Another thing, it's not quite the same thing. If you give people the ability to control things, like just buttons to adjust things, this was on a newsfeed algorithm, they like that even if the buttons don't do anything. So this was a study where where the researchers gave users, I think of Facebook, an adjustment to their newsfeed. It didn't do anything, but people felt much more in control, right? So again, people are easy to manipulate, and there's a risk, and I suspect that I see this in the homework assignment next week too. If you give somebody a requirement to follow, you need to explain this. There's a risk of just checking the box, doing the minimal thing, rather than doing something that the user actually needs, rather than something effective, possibly something that's misleading, right? This check the box compliance notion. You see this, I mentioned this with the Fair Credit Act. There was the intention that the banks are supposed to provide you an explanation. They don't really provide you something meaningful. It requires it's sufficient for the law that they don't get sued, but it's not effective in the sense that somebody could actually really contest this in a meaningful way. And then if you have explanations, you could also game the system. We talked about this. We talked about this in the security part too. If you have Face ID and it tells you these few pixels are off, if you create makeup this way, you would get into the phone. It's probably not the most meaningful, right? So if it's really security critical, explanations, and you only have weak proxies, explanations could even undermine the security of your system or shape the behavior in ways that you don't want. If we provided explanations to farmers in precision agriculture, can you see any downsides? Any of the things that I showed you apply here too?
They would trust the model too much, even if it's against their better judgment.
Okay, yep. So they think there's really enough fertilizer on this part, right? But the model says so, and the model has a Q values here, right? It looks like the model is really smart, so I'd rather provide more fertilizer, right? So that that oversight kind of gets undermined. Anything else? I think manipulating people into trusting is common.
For example, if the model is wrong, they cannot debug the consequences of the model in the real life. Because let's imagine that they understand the model to the extent that is possible, but if really fertilizer was like not correct in this place,
right.
But they cannot debug it because they don't understand.
Right. Or worse, they have a wrong mental model, right? So they think the model here is right for the wrong reason, or the model is wrong for a different reason, right, than it actually is, because they haven't understood this, or the explanations were wrong. Right. All right. Let's get actually into designing explanations. There's this notion of explanation versus transparency. The terms are not consistently used. I tend to use transparency as something much broader. Explanation is more the technique, whereas transparency is how do you explain anything to a human, and it's not just how a model makes a prediction. The first step of transparency is telling people that there is a model in the first place. It's quite sneaky. A lot of systems might use a model under the hood. I don't know how much the judge would tell you that they used a model in the sentencing process, for example, right? Telling them about the presence of a model in the first place might be a way to create some dignity. There's an example, there's a whole thread behind this of somebody trying to hire somebody and they didn't get any candidates. And then they had a friend apply who got screened out immediately. It never reached their desks. It always seemed like they didn't have any candidates. And then they reached out to HR, what's happening here, and turns out they were using a screening model for applicants, and the model was filtering out all kinds of qualified applicants in a way that wasn't understandable. They were, I think, justifiably upset that somebody introduced a model in this thing without ever telling them that made stupid decisions. I suspect, can you think of any other cases where this happened, where people used a model kind of in a sneaky way without telling people, undermining the...
Last year, the Department of Government Efficiency was using models to cut government grants.
I think it was mostly regular expressions, but you can use models for that, and they may not tell you about that. Yep. There's another case that I found surprising. It's a little bit older. It's a colleague here, 2015. A lot of people did not know that the newsfeed in Facebook was algorithmically curated by a model. They thought it's a linear timeline. It was actually quite common that people were not aware that there was a model in there. And then when, as part of this research, they learned about there's a model in there, they felt betrayed by Facebook. They felt like there are certain friends that they thought, this is the title of the paper, I always assumed that I wasn't really that close to her, that they thought that, they were drifting apart because Facebook wasn't showing them the thing. And then when they showed all the messages of their friend there, they felt betrayed. They did a follow-up study where when you told people that there's a model, nothing else changed about the system. The users were much happier with the system and understood that there's something going on, right? I think, at the time, which I find very surprising, 62% of interviewees were not aware of an algorithm, of a model in there, right? And I think there's lots of ways of how we try to sneakily introduce a model into something, to automate something. And I think it can undermine dignity and people can feel betrayed. So it might be a good idea to just tell them in the first place, hey, we're using a model here, and this is roughly how it works or what it does. Right, so if you're using the diabetic retinopathy screening next week, for example, you might want to tell the user that this was an AI automated screening tool, that this was not done by the nurse, right, who maybe oversaw this. Like, even if it doesn't make a huge of difference, or maybe it creates some suspicion, it might still be a good idea from a dignity perspective of people just knowing what's going on. Should I share this? We are partially auto-grading your homework. We never told you about this. Do you feel betrayed now? When you're losing points, a human has looked at this. When you got points, not necessarily always a human has looked at this.
You don't take off points without somebody deciding to take off points.
Yes.
You can still do that at a specific person.
The autograder decides it's either correct or somebody should look at this. It reduced our workload. How much do you feel betrayed now?
Are we allowed to prompt check?
Try it. Allowed? I mean, I'm not taking this as an academic integrity violation if you try. I don't know how many of you tried. Maybe that's a good thing. I don't have a prompt injection defense tool in there. But it's also not an agent, so you can't run any tools in the background. It's a pretty standard LLM as a judge kind of thing. And it's also with a lawyer-approved model, so I checked the FERPA things and so on, privacy things. Anyway, I think, so for the pharma case, I don't know how you can sell them a precision agriculture model without telling them that there's machine learning in there. So that's probably trivial in that case. But you can probably think of lots of other systems where you could sell a product without telling people what's automated, right, versus what's a human. And then we get to the point of how the model actually works. This is the thing that we talked about last time mostly, give you all the tools for this, right? So you might now think of things as Shep force plots. I don't know that you really want to show a non-expert these kind of plots. You can train people to read these kinds of plots. Pretty sure they are not that complicated, right? But it's maybe not the most intuitive thing to show to an end user that has no machine learning training. But think about what information do you actually want to convey? What's the purpose behind this? There is some work, especially in the HCI space, to think about how do I design explanations to be effective for human-AI collaboration. Usually give users some detail about why the precision was made, if this matters to them. This is an example from Google, from a running app, where they essentially recommend a recovery route, and they explain why did I choose this route here. It's a really simple explanation, but it provides some context, right? It's not a force plot or Shapley values. It's something much simpler, but it's trying to address a little bit of curiosity that the user may have, or some transparency of why this was given, rather than just saying we have adjusted your normal route to aid in your recovery, right? This is a very generic statement of what the purpose of the model is. This gives you some insight, even though it's not super precise, right? So the point here is that in a lot of cases, you don't need the most precise explanation. You need to be careful of not manipulating people overly, right? But often, if it's about giving them some dignity, some agency, some control, some oversight, partial information might be sufficient that they build a mental model over time. So let's come to the reading. So in this paper, they tried to ask radiologists, what do they want to know about a model, right? So let's assume we want to augment radiologists. right? So you have some screening here, and it highlights things. I think this was a screenshot of the paper. I have no idea how to read this, but to a domain expert, this may make sense, right? What they did, I think, was a nice technique. It's called a Wizard of Oz experiment, based on the movie. Don't pay attention to the man behind the curtain, right? So the idea here is that you're going to develop this model eventually, but right now it's a human, right? And you can prepare this. So you can often prototype something without building a model by just pretending that you have the model and have a human do this task. So they created a couple of these radiology things, right? Said, let's pretend this is what the model generates, and then talk to a number of humans. What did they find out? Now I'm pretending that you read the paper.
Well, there was big misconceptions about when you're bringing something to aid you that's artificial intelligence, what they want to know about it. Mm-hmm. Like, before reading the paper, I thought it was just going to be, they just wanted the accuracy, how reliable it is.
Yep.
But they really cared about like treating like a coworker.
Yes.
Like, what's his biases, specific ground truth.
Yep. Right. So they want to know much more about what the limitations are in a way that you can't just capture with accuracy, right? We talked about some things of how you could do this by slicing data or maybe using some Shapley values to do some debugging and then some explanation based on that, right? But you wouldn't want to show Shapley values or like highlighted pixels in a thing. That's not what they cared about, right? They wanted to know, how does it fit into the workflow? How does it relate to my coworkers, right? Anything else that anybody remembers? Or just Google it very quickly now? So those are a couple of things that I took out, right? Does it have bias in a specific way? And here I found this very interesting compared to colleagues, right? Some colleagues tend to be more aggressive at diagnosing cancer, others less aggressive. What kind of things is this looking for? Like, how does it work in general, right? So that you have some mental model of when do you need to provide oversight and when not. There's a couple of these things. What are capabilities? What are functionalities? It's very much from a medical point of view, embedded in the medical system. Right? And this is the point from the beginning again. Like the tools that we talked about last time, you shouldn't use them as a starting point. You should think about what do these people need? And that's not often that obvious. And then try to design something that's suitable for them. And you might need to train them with some, this is called AI literacy, right? Help them how to read this. These days, I think it's actually quite often important to downward calibrate trust. So to make people less trustworthy of AI, to make them learn that there are mistakes. And I think something like phishing training, where people send inside companies, test phishing emails to see whether people fall for it. You can do the same thing with AI. Introduce artificial mistakes and try to get people to catch them, to point out these things are not always correct. In a way, the mistake that like 80% of students did last year on the security I3 question was a nice exercise in showing them you shouldn't always trust the coding models to solve your homework, right? So if I could do this intentionally, I would. I think it's a really good learning exercise, right? Find places where you don't trust, that you shouldn't always trust this. So calibrate trust down to an appropriate level where you still have appropriate levels of oversight. You could do this with a self-driving car as well, like introduce, I mean, you don't want to crash, right? But introduce intentional mistakes that you would expect the human to catch. We're not doing that typically. There's also a different article that was very recent about where radiology is right now with AI. We have widely deployed this. Radiologists are about 10 years ahead of software engineers, but being replaced with AI. We can talk about this later. This was like 10 years ago, the big thing, nobody should go into radiology anymore, right? These years, there are lots of vacancies in radiologies. We have a shortage, and it pays about $500,000 a year as a current salary for radiologists. So 10 years ago was really the right time to go into radiology. And we still need radiologists. There's lots of reasons why they don't work that well in practice. They work much better in benchmarks than in the real world. We need the oversight. Some of this is also just liability thing. Nobody is willing to insure a hospital that doesn't have humans look over these scans. But partially also we're much more efficient with AI to do radiologists. So we are doing x-rays and these kind of things for much smaller things. We use them much more frequently, and we still need radiologists. And this one here is also similar to coders. I think in coding, we're not spending 90% of our time writing code, and radiologists don't spend 90% of their time just looking at images and diagnosing things. They make so many other things, and those other things don't get automated with AI. Right? There's a sidetrack here, but I think, again, this is a question of how does this fit into a process. So this is the point that I wanted to get to. How do you actually design something? And to do this, you need to understand what the user needs from an explanation. I want to be very blunt. We as developers are really bad at this, at figuring out what end users want. I can point at past homeworks of how you are really bad at figuring out what patients might want to know. But there's lots of other cases. This is a book, The Inmates Are Running the Asylum, that's 30 years old now, I think, really talking about how developers are really bad at designing tools for anybody else to use. We're okay at designing for other developers, but we're very hard of imagining what does an end user need. And there are techniques to improve on this. So I think, in the first place, don't trust your intuition. If you're thinking next week about you as a patient, what would you want to know from an AI screening tool? You are not the typical patient. My dentist is very proud at showing me that they have some weird AI tool. Maybe I care about seeing a Shapley plot. It doesn't show one, but I don't think the typical patient cares, and I think I'm much more skeptical about them using this in the first place, and the typical patient might be more impressed. But developers tend to be excited about features and implementing things and adding things, not about actually solving the task that the end user needs to solve. It's very end user focused. HCI people would teach entire classes on this problem, right? And how do you build something? So one solution could just be, if you're designing something for end users, get an HCI expert into this, hire somebody. You may not have the luxury of getting an expert on this, so good luck on your own. So let's say you're explaining a cancer prognosis this way. A model explains, oh, I have bad news, you have cancer here. Is this helpful to you? It's clearly not speaking into a language that you can understand. It's not containing the information that you want, right? You're panicked about somebody telling you having cancer. You don't care about any of this thing right now, right? These are past student solutions explaining diabetic retinopathy or cancer screening, right? Yes, it's using some tools that I've shown you on Monday. Just like the previous thing, right? No patient, no nurse will understand this, right? It's like this one here is just a technical version of this, right? This is what a doctor without training might tell you in their language. This is what a data scientist without human HCI training might tell you, right? Here's somebody who created an explanation telling me what the neural network architecture is of the model. As a patient, I don't care. I'm pretty sure that even outside of a few data scientists, nobody cares, right? As a patient, I've just gotten a diagnosis. I don't care what the neural network architecture is. So there are lots of methods of explaining or understanding user needs. This is essentially requirements engineering or design. We talked about some of these methods earlier when we talked about requirements engineering. Talk to your users, right? Interview them. I think Claire didn't spend much time on this because it's kind of boring and obvious, but we're not doing it a lot, right? So,
Time for like 30,000 slides on a lecture. Not my fault.
why didn't you delete some? Don't make it my problem. So, and users often don't know what they want, right? We talked about this back then too. With explanation, it's the same thing. If you ask a user, what explanation do you want, you don't get a meaningful answer because they don't know what's possible and they're afraid of asking for anything, right? Because they think they wouldn't understand anything. So what you could often do is show them what's possible, create some prototypes, and they will create much more creative feedback. We've seen this in our own studies. If you ask with some experiment or some study on with teachers and school administrators, asking them about the model, I don't want to go into details about what they want, nobody has any idea what explanation they want. But if you show them a screen, they can tell you, not quite this, but this is interesting. If you can give me this, this would be interesting, right? Show them prototypes. Do a Wizard of Oz if you need to, right? Kind of create something fake. Don't just ask people what they want, observe them how they work, right? How does a nurse deal with the cancer screening, or what does a radiologist actually do, right? Do user studies. And then if you don't have access to users, and no, we're not going to set you up with nurses or doctors to interview next week, right? This just doesn't scale with 150 students in a class. There are ways to approximate this. Has anybody here worked with personas in the past? Has anybody here startup on personas? Last semester somebody did. Last semester somebody was in the class trying to create a startup, creating personas for all kinds of things, and then try to get all the other students in the class to use it, which is good. I can try to find the link again. So a persona is the idea of, it's a stereotypical description of a person with certain characteristics, and it tries to help developers or designers to ask the question, what would Asaf do? Or any person, right? You have a description and you ask, what would that person do? And it helps you to think from somebody else's mind, right? So you have some description of characteristics of that person. Like, you see this in a second, it's a farmer with a high school diploma, no AI background, right? What do they want to know in this context? It gets you out of the developer mindset and helps you to think from somebody else's perspective. It's maybe not as good as interviewing somebody or observing somebody for a long time, but it's surprisingly effective. This has been used also in software engineering. There's a pretty well-known example of gender-related audits of software usability issues, where you have, so they created a couple of different personas that differed in ways of how they approach technology. Are they people who are willing to click around until they understand the system, or people who are nervous to click around and want to understand how the system works before they click on everything, right? So it's based on some past research of how people kind of approach systems, and now you can think of this as from two different perspectives, right? What would Pat or Abby do in this context? Pat wouldn't click around here, right? That's not how she works. I might mix up the personas, right? Abby would give up immediately when they see the screen, right? There's no documentation here. So it helps to think from somebody else's perspective. And these days, again, there was startup, you can have, LLMs are pretty good at role-playing, right? So you can instruct a model to behave like a specific role and then ask it questions. Again, not necessarily the same thing as talking to actually people, observing them. Here's an example where I instructed a chatbot to behave like a patient who's maybe a bit skeptical of the medical system. And then up there is a diagnosis. I have some bad news, the block of text that I showed you earlier. And then here the answer, the patient looks confused and a little anxious. And then below, I don't understand these words. what is this mass inside of me? Is this something dangerous? Did it grow there? And so on, right? So I think this helps to really to point down what do they want to know, or to test things, like how would they react, especially if you're doing this with text. Does this make sense? This is one of multiple possible techniques that I want you to play with next week when you're looking at this diabetic retinopathy system. You can also do other things like hazard analysis, forces you also to think from the outside. Right, but either talk to a real person or try a chatbot or something like this, and then also think about how this is embedded into the system. So I want you to try this now. I want you to play with a chatbot, pretend that the chatbot is a farmer. You can think about the background story of that farmer. Maybe it's a farmer with an AI degree. Maybe it's a farmer without one. And what do they want to know about the precision agriculture system? Experiment with this, and what I want you to know is, what have you figured out maybe based on the interaction of what explanation you could provide to them? What's the purpose? Try to think of one of the purposes that we talked about earlier. And playing with this persona, has this changed your mind in any way? Have you learned something new? Does it make sense? I'm going to give you about 8 minutes. Have fun. I think it's a good time to maybe talk about, have you discovered anything interesting?
We talk about, like, for example, giving metrics to the farmers, like the nutrients percentage in the soils, so it is going to be able to understand the conditions or the status of the plants, and it can form like its own reasoning or own understanding of why that specific amount of fertilizers is needed for that plant.
Mm-hmm. So don't only provide the end recommendation to add more fertilizer, but also intermediate results or inputs, right? Yep.
You were talking about, like, in order to provide explainability, even provide images to the farmer, because they'll be able to relate to that much more than just words or data facts.
Is this what the farmer told you?
No.
Are you thinking
from
your developer's perspective what the farmer would do?
Maybe from the farmer's perspective, I would say, if they see the images directly that, okay, this certain piece of soil is or land is not well fertilized, then it will give them more confidence.
Okay. I am just trying to sense how much you're using your own judgment as a developer, what you would like to see versus...
Why do you assume that none of them are gardeners, Christian?
That was intentional. I mean...
I'm a gardener.
But precision agriculture in your garden?
No. I need better groundhog.
Go ahead.
Okay, so my ChatGPT farmer, his name is Bob. He lives in Alabama, lives in a small farming village. He's really nice, but he told me that he wants to hear from someone else from another farm in a situation that this product is working for them, because he's like, I don't know the technology, but like I know other people in the field, and yeah.
So that's a very different kind of explanation, right? So it's evidence that the thing works, but not just accuracy, right? Maybe indirectly as a testimonial from somebody else. What else?
A kind of new thing that I kind of realized was that a lot of decision making is with regards to cost, which is not something I thought of before. So it's not that they want to understand, but also why is a certain fertilizer being used in a certain area more, because now they have to pay more, which is very important for them. So yeah.
Okay. Any other insights? Well, maybe what did you think of as a purpose here for your recommendation?
I think like one thing is to give farmer the agency to also think about how to improve this process, because farmers, they actually have a lot of insights and experience. They just may not be able to gather all this information as quickly as the AI can. So letting to see the explanation also make them maybe have more better input into the model in the next iteration.
Okay.
And I can read it for a second, actually. So, I know we saw that with radiologists and doctors, but that was something that was told to me 20 years ago about developer tools, that developers wanted to understand where a suggestion came from, and if it was wrong, they wanted to feel like they had agency in fixing it, which I think is still true.
Mm-hmm. For program repair?
For anything.
Yep.
At the time, it was static analysis and repair. But also, I wonder, I imagine farmers might not be, it seems pretty human, actually, more than developer-specific.
And I think as developers, we can empathize with developers, right? But it's much harder to develop empathy for somebody else. What was the experience of using a chatbot for this? Was this... Go for it.
Okay, this one's slightly irrational. I've been laughing about it for the last 5 minutes, but I think the point would just be to let the farmer try out a system like this, and the results will speak for themselves. So how do you even get the farmer to try it in the first place? Just to bring about some like whimsy, maybe you can say like this is a magic system, like speak their language, like make it relatable, bring like a fun element. And yeah, it's pretty irrational, but if it's a gardener, like gardeners like magic, like gnomes and fairies and I don't know. I've been laughing for the last 5 minutes.
You need to be careful in those settings to be not condescending, right? So people like looking down on people who don't have a PhD in AI, right?
But there is a, if we can try and add some.
I'm not saying that
superstition is maybe a thing. Like I can see playing into that in a way that's not
Yeah, no, I'm not saying not to do this, right? Just be aware of a tendency there of projecting stereotypes, right? So if you're doing this, you really want to field test this probably, right? Actually talk to real farmers to see how they're reacting to this.
Christian, where are the Skittles?
You didn't give them to me, probably in your office.
They must be in my office. I'm very sorry. I will bring them next week.
On a similar note, when my ChatGPT farmer Bob from Alabama asked me why he should use it and he wanted testimonies, I told him that there's no one else using the product yet. What convinced my ChatGPT farmer is that I told him I'll give him a 3-month free trial to use, and that he can be the testimony for other farmers. And that convinced ChatGPT, and I guess that is why companies give out free trials for stuff.
Yep. All right. So I hope the higher level point here came across a little bit, right? Don't trust your own intuition when it comes to end users, right? Especially people who are not like you. And don't think just in terms of stereotypes. There are lots of techniques. If you can get help from a UX expert, HCI experts, do that, right? They are trained in these methods. If you don't, do the next best thing. Talk to people, try chatbots, things like this. I have one more thing that I briefly want to get to. This is something that we discussed with some collaborators in sociology and medicine, actually. The field of training medical students, they talk very deliberately about clinical communication. So when a doctor is talking to a patient, they need to explain what's going on, independent of whether there's AI, right? So you've just been diagnosed with cancer. They need to have a conversation. The key purpose of that conversation is typically informed consent for the next steps. And it's mostly not that you're trying to give the patient choices and pick. You're making a recommendation and you want their buy-in, right? So it's part of this is persuasion. The patient can say no and get a second opinion, but it's not really a negotiation between you and the patient. What they're really realizing is that there's this huge hierarchy in knowledge and power between patient and doctor. We broke that down over the last 40 years or so with patient advocates or so on. In the past, it was mostly doctors saying what the next step is with very little agency to the patient, undermining their dignity. We've gotten much better at this. At this point, we're explicitly training medical students in how to communicate with patients. And that has a lot to do with realizing the switch in perspective. You're not communicating to another doctor. You're communicating to a patient who doesn't have the same medical training as you. It's not about giving the most precise explanation. You can't explain the neurons in your head anyway, right? But providing enough context that's understandable to the patient. It's partially persuasion, partially explanation, partially providing dignity to the patient, that they know what's going on. It's really tailoring to the patient's knowledge. You don't speak to every patient in the same way. And you try to avoid confusion and overwhelming the patients too. So you're not giving them all the information at once. Less is often more in this context. And this is something that has developed as a community of practice, as rules, as norms. This is something that's part of training that you could get sued over if you don't explain things to a patient, but also practice. So we talked with people who teach this to students. So this is part of clinical practice. You're explaining something to a patient, you're getting feedback on this. During med school, they do this with fake patients too, right? So you're role-playing with fake patients and getting feedback on this. And there's an understanding, if we don't do this, we're losing trust in medicine as a field. We have, especially people who are less well-resourced or have backgrounds of bad experiences, may not trust us ever again, may not trust a doctor again, and we have passed really atrocious racial experiments and so on, Kigigi trials, and so on, that undermine confidence in medical establishment for many subpopulations for a long time, and they realize they need this for trust building too. Right? So this is important, not important for every single product out there, but I want you to try this. And it's really hard, kind of getting explanation right is really hard. We don't have fixed tools. It's not just apply SHEP to everything, right? And this is essentially where I want to leave you today. So transparency goes beyond just these explanation tools. It's not just what were the factors that went into a prediction. Think about the entire system and why somebody wants an explanation. What's the purpose behind an explanation? And recognize that you're probably really bad at having the empathy or the perspective of the end user. So really take steps to understand their perspective, right? Talk to them, observe them. Use a chatbot if you have to, right? Do other techniques. And yeah. I hope you have some fun trying this next week, and then see you Monday.